Hello, in this presentation I will talk about the final system for the Raspberry Pi and GUI. Over here we have an overall system block diagram for the final product. The highlighted area represent the microcontroller DSPIC33, the Raspberry Pi, and the touchscreen. As we can see here, data will be sent and received between the microcontroller DSPIC33 and the Raspberry Pi. Data will be displayed on the touchscreen. The user will be able to press on several buttons on the touchscreen and select several values, and based on those selected buttons and values, the Raspberry Pi will respond and take several actions. Over here, this is a saving file. This file will store all the workout data that will include the RPM, rotation, and torque for left and right motor. Also, it will have a maximum values for RPM, rotation, and torque, as well as the speed and the workout time. This file can be uploaded to a flash drive. It will be located on the desktop of the touchscreen. This is the final design for the touchscreen. As we can see here, this is the workout type that the user can select. We have two types, either exercise mode or dyno mode. This is the wheelchair size. This value can range from 20 inches up to 26 inches. This is the resistance level of the workout. It can go up from 0 up to 100%. Those are three buttons: the start button, pause button, and end button. This button over here is it will be used to start the workout. This over here will pause the workout, and this over here will end the workout. This is a workout duration. The user can select workout duration. It can go up to 60 minutes. And this will be the displayed time during the workout. Over here we have three data that will be displayed during the workout. That will be the torque, speed, and distance for each of the left wheel and the right wheel. Over here, this diagram represents the data communication with the Raspberry Pi. As we can see here in the middle, we have the Raspberry Pi. On the left side, we have the touchscreen. On the right side, we have the DSPIC33 and the wheelchair dynamometer. The Raspberry Pi will tell the DSPIC when to stop and receive data. It will also send the DSPIC the selected resistance level, wheelchair size, and exercise type. The DSPIC33 will send to the Raspberry Pi the following data that will include the RPM, rotation, and torque, and duty cycle for each of the left motor and right motor. Over here we have several flags. Those represent the buttons on the touchscreen. So whenever the user presses on several buttons and select different values on the touchscreen, a certain flag will be raised and then sent to the Raspberry Pi. And based on that, the Raspberry Pi will send different data packets to the DSPIC33. Now the connection between the Raspberry Pi and DSPIC is going to be done by RS-232 cable. This is a UART cable. The communication in this final product will be done through a UART serial connection. As I mentioned earlier, the Raspberry Pi will be receiving data from the DSPIC33. That received data will include the RPM, rotation, torque, and duty cycle for left and right motor. After receiving those data, the surface speed and distance will be calculated, and that calculated data will be later displayed on the LCD touchscreen. using the GUI. Now the message format for the data that will be sent from the DSPIC 33 to the Raspberry Pi is over here. That will include the RPM, rotation, and torque and duty cycle. We can see here the $sign represent a receive character. This character is used only to indicate that a new data packet has been received. And then at the end you see a bound key. This is the terminating character. This character is used to indicate that the data package has been completed. The RPM will be sent to the Raspberry Pi in order to calculate the surface speed of each of the right motor and left motor, as well as the rotation will be used to calculate the surface speed. Torque will be sent to the Raspberry Pi in order to be displayed on the touchscreen during the workout. The duty cycle will be used to vary the mechanical resistance. In order to test the received data packets on the Raspberry Pi, I use an Arduino Uno. Over here, this schematic explains the system that was created. We have a USB cable connecting between the Raspberry Pi and Arduino. The Arduino will send the same data packets that the DSPIC will send into the Raspberry Pi. So the software part of the Raspberry Pi will not change whether we're using Arduino or DSPIC 33. And based on that test, the communication was working correctly and data packets was received correctly on the Raspberry Pi side. As we can see here, that's the Arduino Uno and that's the Raspberry Pi. This cable over here, that will represent the USB cable. It will be connected on the USB port on Arduino as well as the Raspberry Pi. Now for the data that will be sent from Raspberry Pi into the DSPIC, the DSPIC will notify the DSPIC when to start and receive data. The Raspberry Pi will send the selected resistance value. This value will be selected by the user. Also, the Raspberry Pi will send the wheelchair diameter. That will be the wheelchair size. This value will be also selected by the user, and then after the user select that value, it will be sent to the DSPIC 33 after pressing on start button, as well as the workout type. As I mentioned earlier, we have two workout types. We have the dyno mode and the exercise mode. So the user will select each of the resistance value, wheelchair diameter, workout type, as well as the workout duration, and then he will press on start button in order to begin the workout. Now when data packets are being sent to the DSPIC 33, over here that will be the global message format. It's similar to the packet I mentioned earlier whenever we send data from DSPIC 33 into the Raspberry Pi. So the first character will be the receive character. As I said, this character is used to indicate that a new data packet has been received. And then the next character, it will tell the DSPIC 33 when to start and stop receiving data. Now when the user presses on start, the Raspberry Pi will send number 1 to the DSPIC in order to make the DSPIC start receiving data. When the user presses on pause or end button, this character over here will be 0. And then over here the next character is the resistance value. This value will range between 0 up to 100%. Over here we have the wheelchair size. though this will range between 20 up to 26 inches. And then we have the exercise type that will be either dyno mode or exercise mode. Whenever it's exercise mode, the Raspberry Pi will send number 0 to the DSP33, and whenever the selected workout type is dyno mode, the Raspberry Pi will send number 1 to the DSP33. And at the end, we have the bound key character. This is the terminating character. It will be used to indicate that data packet has been complete. Over here, as I mentioned in the previous slide, the Raspberry Pi will notify the DSP when to start receiving data. So when the user presses on start, you will see number 1 on the first character. When the user presses on end or pause, you will see number 0. For the workout type, we can see at the end of that packet we have either 0 or 1. When it's 0, it means we have exercise mode. When it's 1, it means we have dyno mode selected for the workout. And over here we see that's the resistance value. So this is just an example. If the selected value is 50% for the resistance level, this will be sent to the DSP33. And as well as the wheelchair size, if the user selects 22 inches, over here we can see that 22 will be sent in the data packet. Now, in order to test the data packet that will be sent from the DSP33, from the Raspberry Pi into the DSP, I constructed this circuit over here. This schematic represents the connection between the Arduino, the serial monitor on the computer, and the Raspberry Pi. The Arduino was used in that test. Also, a software was uploaded to the Arduino Uno in order to receive data from the Raspberry Pi. This part over here is explained in a different video. It shows how the Raspberry Pi will be sending data to the Arduino, and then that received data will be displayed on the serial monitor. So whenever the user selects several buttons on the touchscreen, different data packets will be sent to the Arduino, and then the packets will be displayed on the serial monitor. Now for the final product, whenever we're using a DSP33, I just want to indicate that nothing will be added or changed on the Raspberry Pi software. So this was only constructed for testing purposes, only to confirm that the Raspberry Pi is sending the right data packets to the Arduino Uno. Over here, this is the connection that was done between the RS-232 cable and the UART pins on the Arduino. After doing that test, the Raspberry Pi was sending the right data packets to the Arduino, and based on that, I can say that the Raspberry Pi is ready to be connected with the DSP33 and send the right data packets. Thank you for watching that presentation. That presentation represents the final presentation for the Raspberry Pi and the GUI. In the next video, I will show a demo video that explains how the final system will be working on the touchscreen. Thank you for watching. Bye-bye.